Hello. So we talked about sequences 2 classes ago. We talked about arithmetic sequences, and that was when you had a sequence that was increasing or decreasing by the same number every time. Today we're talking about a geometric sequence. And a geometric sequence is a sequence, it's a pattern, and I've talked about it in each class, but now I'll give a definition to it. A geometric sequence is defined as, and I'll write it here, a sequence in which each term after the first is the product of the preceding term and a common ratio. So it's a sequence in which each term after the first is the product of the preceding term and a common ratio. What that means is it's a sequence in which from term to term you're multiplying by the same number every time to get to the next term. So you're not adding now we're getting into multiplication. So with arithmetic sequences we had D, or a common difference. With geometric sequences we have R, which is also called the common ratio, and that is what is being multiplied each time to get to the next term. So common ratio, to define it, it's basically the multiplier. And if you want to find it, well, think back to arithmetic sequences. To find D, you would take a sub 2 minus a sub 1. Just subtract 2 of them and you get the difference. For geometric sequences, you just divide. If I want to find the common ratio, I take the second term, divide it by the first term, and that's going to give you your common ratio. Okay, so there is going to be a formula, just like there was a formula for arithmetic sequences. There's a formula, and we are going to derive it. We're going to kind of look at where it comes from, just like I have with all the other formulas. So look at this geometric sequence. It's 2, 10, 50, 250. Okay. So I want you to look right down here where this pattern is. It's not writing. There. So look right down here where this pattern is. Okay, so the first term we're just going to call a sub 1. Okay, so we have a sub 1. I don't know why it's not tapping. So the second term, how would we get the second term? Well, to get the second term, you take the first term, a sub 1, and multiply it by 5. To get to the second term here, 10, you would take 2 times 5. Okay. Let's look at how we get the third term, 50, if you will. Well, to get the third term, we could go back to the first term, a sub 1, and multiply that by 5 again. So if I want the third term, I could take the first term and multiply it by 5 2 times. Or in other words, a sub 1 times 5 squared. And that's how we're going to start to derive this. So you take the first term times 5 squared. Well, if I want the fourth term, it would be a sub 1 times 5 3 times. Or in other words, a sub 1 times 5 to the third power. So you can kind of see what's happening here. If you want a sub n, so if you want the 10th term, the 20th term, the 100th term, we'll call it a sub n. You take the first term, whatever it is, take whatever the first term is, times the common ratio. In this last problem it was 5, so we'll call it r, to the n minus 1 power. And understand what's happening here. So look here, if we were looking for a sub 4, the fourth term, notice the exponent here is to the third term. We would need to multiply the first term by 5 3 times. So you're multiplying by the common ratio 1 less than the number that you're looking for. And so that's the geometric sequence formula. Just like we had an arithmetic sequence formula, here's the geometric sequence formula. Okay, and we're going to use that to solve some problems. What I have next here is some interest problems. We already did interest first semester. I really don't want to hit on it again. I don't want to touch on it again just because of time. And so what we're going to do is kind of skip the application of this stuff in terms of interest and just go back to some other examples. So go to the next page. And we're going to look at example 1. It says, find the first 4 terms of the geometric sequence. You know a sub 1 is 4, r is 3. Well, I said if you guys can find a way or problem solve to get to the answer, then do it. If you don't need to use formulas, then don't. If you know the first number is 4, and then you know that you're multiplying by 3 every single time, because that's what the ratio is. I don't know why it won't mark right there. Then you know the next one's going to be 12. Multiply by 3 again, you get 36. And then multiply by 3 again, and you get 108. So there's the first 4 terms of that geometric sequence. The first term is 4, and the ratio is 3. There you go. My stylus is not working, so I will use my finger. All right. Next one, find the first 4 terms of the geometric sequence. Well, we know the first term's -1. Your ratio can be a negative. Just like when with the arithmetic sequences you could subtract each time, it could decrease, your ratio could be a negative number, where you multiply by, in this case, -2 every single time. So you start with -1. If you multiply that by -2, then you get 2. If you multiply that by -2, you get -4. And if you multiply that by -2, you get 8. And there are the first 4 terms. You see the signs can alternate there. Okay. Well, now let's talk about using the formula. So it says find the specific term of the geometric sequence. You know a sub 1 is 25, r is 1/5, and you're looking for the 6th term. So I'm going to use the formula here. I'm looking for a sub 6, the 6th term. So the formula, I'll write it over here, it's a sub n equals a sub 1 times r to the n minus 1. So for a sub 6, it's going to be a sub 1, which is 25, times 1/5 to the n minus 1. Well, n is 6. I'm looking for the 6th term, so n is 6, so 6 minus 1. So now I just need to use my calculator and do 1/5 to the, make sure you don't multiply these together first, that's a no-no. Take this to the 5th power. So 1/5 to the 5th power, I would do that in the calculator, and then multiply that by 25, and you get 1/125. All right, 2 more. It says find the specific term of a geometric sequence. You know a sub 1 is -1/2. You know the ratio is -4. You're looking for a sub 6. All right. So a sub n equals a sub 1 times r to the n minus 1. So for this one, it's going to be -1/2 times r, which is -4, to the n minus 1. Well, n is 6, so 6 minus 1 is 5. So I take my calculator, and I would make sure to do -4 to the 5th power first. And make sure you use parentheses in your calculator. If it won't matter on an odd power, but on an even power, parentheses are going to matter. So notice I put parentheses in there. So -4 to the 5th power times -1/2 is going to be 512. That would be the 6th term in that geometric sequence when you start with -1/2 and you multiply by -4 every single time. All right, last one. Find the specific term of the geometric sequence. You have 1/2, 1/4, 1/8. You're looking for a sub 10. Okay, so let's list out what we know. We know the first term is 1/2. We don't know the last term, and we don't know r. R is not given, but we can find r. R is when you take the second term divided by the first term. So if I take 1/4 divided by 1/2, I'll get the ratio. And you might look at these and see it right away. I mean, you could look at that and say, oh, it's multiplying by 1/2 every time. And that's fine, but I do want to show mathematically how to do it. So it would be 1/4 times 2. So 1/4 times 2 is 1/2. So your common ratio is 1/2. So you have a sub 1 is 1/2. Your ratio is 1/2. You're looking for a sub 10. So you're going to take the first term, 1/2, times the ratio to the n minus 1. So in this case, 10 minus 1 is 9. And so you do this. You do 1/2 to the 9th power times 1/2. You get 1 over 1024. Since the problem starts with fractions, make sure you end up with a fraction instead of then going to decimals. So that's geometric sequences. That's the formula. I will say on your assignment, it does get a little more challenging. Some exponents are going to be thrown in there, variables, things like that. But you should have a decent amount of time to work on the assignment, look at the key, get some help in that regard, and help each other out while you guys are working. So some of those problems can get rather difficult. All right, so just wanted to throw that out there. So good luck, and I'll see you guys next class. Bye.